All right, let's continue here. We just finished helping Leo compute his target time, because it's like, oh my gosh, for me to be at the same speed as her relative to my group so I can rank the same, how fast do I need to run? What is the performance time that I need to reach? So this is equivalent to the exercise that I walked you through in the lecture videos, where we had the percentile, desired percentile, and then we wanted to know what score referred to that percentile, right? So for that, instead of using P norm, we used Q norm. Leo wanted to be in the same percentile as Mary, so that's 0.62. And then we needed to use parameters of his distribution and raw parameters because we wanted the actual raw score back, right? So the interpretation here, if you run, right, like we did before, 4,492 seconds is the time he needs to reach. So recall that Leo's time was 4,948 seconds. He needs to reduce that time to 4,492 seconds, 6 seconds in total. No? Well, that's odd. Oh, sorry. This is right. So it was 4,948, and he needs to go to 4,400, so about 400 down seconds, just to catch up with Mary. Now, when you told Mary the results and you told her, hey, here's her percentile, she was thrilled and felt empowered to do better. She said she wants to be at the fastest 30%. So she asked you to compute the target performance time for her. So let's help Mary get her target for improvement. So to do that, again, she has a target percentile, which is 0.30. She wants to be at that. So translating, like I'm trying to work with you on that communication of statistics without statistical jargon. So when she tells you, I want to be in the fastest 30%, she wants to be on the 30th percentile. And what does that mean without statistical jargon? It means that she wants to be behind in performance time of only 30% of the athletes, right? She wants to be on the bottom 30%, right? So it's good to kind of go back and forth between the statistical term, which will give you parameters to defend your argument, to present information to people, but also understand precisely what that means. Hang on, where were we? So there you have it. So this will be question 4. I have the numbers all wrong here. And this is the performance that she would need to achieve to get to 30%. And this is where she was, 4,948. So she doesn't have to go as much down as Leo will have to do to reach her. So maybe you should say, well, maybe put a target that's a bit, more challenging. So question 5 will be this one. If Mary wanted to be exceptionally fast, what target time should she shoot for? Because on the 30th percentile, the probability of getting her score or lower is 0.3, much higher than the accepted cutoff for exceptional and atypical, which is 0.05. So can she do better? What she should shoot for to get to that exceptional mark? And again, let's call exceptional scores that fall on the 5th percentile. Only 5% of athletes would have shorter times than her. So you should have your box there by the time you see this video. And what we need to do is to get target time from Mary, number 2. And what we want is to give her, put her on the bottom 5%. And Again, the rest remains the same. So that means that to get to be, this is odd. I was going to record over my mistake, but I want to show you how we all make mistakes and when we're coding, even if you're experienced with it. What happened here that I'm getting, look at what while I was puzzled. The 30th percentile score was this. And then the 5th percentile score was the same. And I was like, this can't be true. But R is probably not making a mistake. I'm probably making a mistake, and this is why. I stored the target performance time related to the 30th percentile in the variable called target time for Mary. When I type target time for Mary, that's what R will give me. Then I asked R to compute the target performance time if she wants to reach the 5th percentile, and I stored that at the variable target time for Mary too. But then I asked R to report target time for Mary, and then it consistently reported the same thing. So this is the problem. So there, if you fix it, she needs to bring that time down about 1,000 seconds to be exceptional at the task. All right, this is it. I hope you guys enjoy it and take your time figuring out what things mean on this lab so that you can do the independent lab successfully. I hope you come on Wednesday with questions about the independent lab. Bye-bye.